Hello everyone, welcome to this tutorial. Today we are diving into something really exciting like Microsoft Florence 2, which is honestly one of the coolest AI model I have ever seen. If you ever wonder how can we get a single AI model to do basically everything related to computer vision, from describing to images to detecting object to segment parts of picture, this is the model you are looking for. Think about it in this way. Imagine having one model that can do any task you like object detection, image captioning, object segmentation, and OCR. So, before diving into this tutorial, we will check what its research paper tell us about it. Now review its research paper. It's named Florence to Advancing a Unified Representation for Variety of Vision Tasks, which is a befitting name for this model. It's a novel vision foundation model with a unified and prompt-based representation for variety of computer vision and vision language tasks. Means it's a novel approach and it take prompt-based data or images to perform its vision computer vision tasks or vision language tasks. Vision language tasks means it take images and textual prompt both together and put it in a model to get results. So, Florence 2 were designed to take text from which I have described as text instruction and generate desirable result in text forms, whether it's be captioning, object detection, grounding, or segmentation. It's trained on FLD 5B dataset encompassing of 5.4 billion comprehensive annotation across 126 million images. So let's get to its architecture. As you can see, this is the architecture of Florence 2. It's a multitask prompt, means it takes various type of prompts, or it means tasks like object detection, segmentation, OCR, and an image. Then both it's get into embedding. It can be visual and text and location embedding. Then that result is go to through transformers encoder, then transformers decoder, and the result is generated as either text or location tokens through which we describe what's an image or what based on the task we have provided it. Like in here you can see person riding a red bicycle on road. What are its feature? So its image level understandings means it understand a higher level semantics and foster comprehensive understanding of images for linguistic description. Like using text prompt, it can understand the meaning of the image, means semantics of like if object is on some other object and understand it the image like how the object is in a relationship with another image. So another feature is its reason pixel level recognition, like facilitated detailed object and entity localization between images in capitalization with object and their spatial context. Like I previously said, it's also done in pixel level, like it's a very detailed model to understand objects and relationship with its environment, like its color and how it's a relationship with other objects of same category or different category. Then another feature is fine-grained visual semantic alignment. Task require fine-grained understanding of both text, images. It involves locating the image region that corresponds to text phrases such as object attributes and relation. Like it's a feature that means like you text the textual description we have given it is also has a relationship with the images. Like if I have detected this object, so where is this object is and how it is with other object using textual description. So let's t- go through it through more. So as you can see how it's work. So You can read about it in our notebook more. Let's get to the uh, actual code implementation of Florence 2. Let's see how can you perform various vision tasks using Florence 2 on your own. So we have to first install some libraries which are Transformer, Request, Torch, Pillow, Matplotlib, OpenCV. The most important is Transformers here, as I am going to use Hugging Face library to import some classes. So let's run this now. Import those modules in our environment. After that, I have to choose between CUDA or CPU. If CUDA is level, then device will have CUDA, uh, and otherwise it will have CPU. So this is the most important class you have to import. From transformers, we have to import auto processor and auto module for casual LLM. So we create two instances of these class model for auto model for casual LLMs, from which I import this model, Microsoft Florence to large. So this is the model you have to import to perform Florence 2 on your own. And the processor is needed to resize the images in the format which model requires. So let's run this. While running, we will in, download a sample image on which I am going to show various vision tasks I am going to perform. So as you can see, this is the example image I have taken to perform various vision tasks for Florence 2. As you can see, it contains various objects like camera, books, a vase or a bottle, and a table and a blur background. So we have to first create the function to perform Florence 2. This is the function I have created. It's take a task prompt in which I will uh, tell the model which task I have to perform and the image on which I am going to perform. If that task prompt require a text input, I will perform or give it here, or if not, it will be a none. So the image is converted to RGB format. The processor is taken the argument of prompt, which is this as you can see as a textual prompt and image as an argument, and return the inputs. Then the input is gone through a model dot generated, which is converted into the model format, and that is gone through the batch decoder, which have you seen in the architecture. So that generated test is gone through here as post process generation. The after the result, it's converted that result into the human readable format. So this part converts the model data into human readable format. So, and after that, the result is parsed as return. Let's run this. So, our first vision task is image captioning. As you know, image captioning is describing what's going in image. Like if there is an apple on the table, it will say there is an red apple on the a brown table or XYZ. Let's it have in Florence too. There are three ways you can perform captioning: a simple captioning, a more detailed captioning, or a more detailed caption. Let's see what's happening in caption. So, as you can see, a camera sitting on top of a stack of books next to the a vase of flower, which is right. As you can see, there is a camera sitting on a book next to a vase of flower, but it doesn't mention anything about the bottle. But bottle is also a primary object here. Let's see what's happening in detail caption. The image show an old camera sitting atop a stack of books on a table, which is with a flower vase beside it. The background is slightly blurred, giving the image a dreamy feel. It's tell the semantics of the image quite well, like the age of the camera. It's an old camera sitting on a top of books, which is right on a table with a flower vase beside it, which is right. And it's also tell about the background of the image, like it's a blur background. It has said it is slightly blurred. What feeling that image is giving means it's giving the image a dreamy feel. Let's see what happened with more detailed caption. So, in detail caption, it say the image show a stack of old books on a wooden table. On top of the books, there is a vintage camera with a black body uh, and a silver lens. Next to the camera, there are two glass bottles with labels on them. The bottles are filled with small pink flower. Background is a dark gray wall with a subtle texture. The overall mood of image is rustic and vintage. So the first one I mentioned, it has mentioned about the two bottles here, which two glass bottle precisely. Like this detailed caption and caption doesn't mention about two bottle. It's all every time it say about this bottle as a primary object, but not about this. As so it mentioned about two glass bottles, which was not mentioned previously in any of the captioning format. So it's a quite good here. So another thing is that it's give generally the same meaning as this, but it's also tell about what kind of books. Like it's a stack of old books. Here it's a only a stack of books, means it's telling about the age of the books, or also about the wooden table, like what texture the table is of. So it's meaning, if we have to explain in simple terms, it's telling detail about every object it see. Like for like for books, it tell about it's a stack of old books. Of table, it tell about wooden table. A camera, it's a vintage camera with black body and silver lens, and also the location of camera to the bottle. So it's give the more detailed description of the image. So it's based on you what kind of captioning you want for your task. If you want a simple captioning, like a person is standing in front of door, this will be enough. But if you want a more detailed captioning, like if two young boys are fighting in school playground in beside the swing, so more detailed captioning will be better option. Now let's get to another uh, vision task of Florence. Our next computer vision task of Florence 2 is object detection and recognition. First, we have to create a helper function which help us in visualizing the model output with images. So I will run this function now. Our first task prompt is object detection, which is represented using OD. I will provide that task prompt to a model and run it. I am printing the result of the models. This is giving me the bounding boxes of the object. As you can see, these are the and also providing us with the labels of the object it have detected in the image. These are right. There are four instances of books, one instance of portal, and one instance of camera and vase each. Let's visualize this on image. As you can see, after visualizing this on image, you can see it is done quite well. So the camera, the books, and the bottle and vase. Now, the next task. The next task is dense region captioning. Means it's let's show you to a visual with same as previous in detecting the bounding boxes and the objects label, but it's also telling us the relationship between the other boxes, like the other objects like vintage book on wooden table. Let's see it visually. As you can see, it's telling about a visual medical book. It's also telling about vintage book on wooden table with cherry blossom branches in glass bottle. This is the description of this person. This is the description of this person. So let's get to our next task prompt, which is reason proposal. Let's run this. As you can read same as previous, but it is only giving us the bounding boxes of the object, not the label. As you can say, labels are empty here. Let's run this. You are seeing it's that giving us the information of all the object it has detected, but not the labels of the objects. So these are all the objects it has detected currently. Let's get to our next computer vision task. Our next computer vision task of Florence 2 is segmentation. First, we have to create a helper function to represent that output visually. I will run this helper function now. Let's get to our task prompt. First, our task prompt is differing expression segmentation. In this, I have to give the textual input like camera, which is the object in the image, as an argument to our model, and task prompt, which is referring expression segmentation and image. And the result is the segmentation mask of the camera. As you can see, it has lots of values in it, but we have to visualize it. Let's see what's happened in images. As you can see, the object has been detected and clearly segmented by pixel perfect level. Similarly, you can do it with other objects like book. These are the book object in the image. Let's see what happens. As you can say, every instance of book has been segmented. Let's get to our next. Let's take text input as portal. As you can see, it has segmented the bottle in the image. Now, our next will be vase. As you can see, it has segmented the vase clearly. Next will be cherry blossom branches, which are these. Let's segment it. It has segmented a cherry blossom, which is a kind of general segmentation, but it's quite good for the model. It is. Uh, Next is task prompt is caption to phrase grounding. Means I have to give a text input of caption what is in the image, and it will ground it into image. Like if I have to the image, the apple is on the table, so it will label the apple and the table together and leave everything else. As you can see, the old camera, books, a table, a flower vase, and a flower vase here. It has taken both bottle as flower vase, which is currently wrong. So with this, the segmentation part is over. Let's get to our next computer vision task. Our last computer vision task of Florence 2 is OCR. For this, I will take another image for a sample. Let's show you the sample image. As you can, this is the sample image I am choosing. It has a textual part which is going to be used in OCR detection. Let's give the OCR as a text prompt to the model. As you can see, it has read you are another line not another line stuck. You are just scared to start. So it is detecting this part clearly and another object, another textual entry also. Let's see what with the region. This is the task form I have to provide OCR with reason. It gives the bounding boxes of the OCR it has detected with it. So to to visualize it, I have to create another helper function. Let's draw the OCR bounding boxes on the image. So if you see it, you are saying that you are not stuck, you are just scared to start. And other OCR are coco.com and this. It has performed good, quite well for a all-purpose model. With this, our tutorial on how to perform vision tasks using Florence 2 is over. You can read about it in more detail on our labeler website. In this blog, I have tell in detail about Florence, what it is and what other things you can do in greater detail. Please check it out.